Okay, so hi everyone. Today we're going to be discussing two topics in Form 4 because we've we've covered the topics that I think are heavy topics lah. Okay, the first 3 weeks of our holidays, I covered three topics that I think are very heavy because banyak soalan dari sana in paper 2 and in paper 3. Okay, but now we come to the last one, which is a Form 4 segment, and we're doing two topics. Okay, so we're going to be talking about paper 2 questions from the topic of forces and motion, because there seems to be that is a little bit more heavier than the rest of the topics, I feel, especially in section B. And then after that, in paper 3 section, I will probably do that in the last 45 minutes. I will talk about experiments from light. Okay, two light experiments that I think are important for us to cover lah. Okay, and then and this is our last physics session. Okay, before kita kembali ke sekolah pada minggu depan. So I hope that if you're watching this from YouTube, I hope that all the 4 sessions have given you a good enough base, okay, for you to do a more focused revision. Okay, I'm not saying that the other topics are not important, okay, but I'm saying that this is I mean, you guys are a very diverse bunch lah. There are some people that are very good, and there are some people that are not so good. Okay, so I want to make sure that the people that are not so good in it are not left behind lah. So I want to give you all these tips to help you. Okay, and if you're already good at this, the stuff that we have covered, then go ahead and cover other stuff. Okay, jangan berpuas hati ya dengan setakat apa yang kamu telah capai lah. Okay, that's the point of all these sessions. Okay, so we're going to begin by looking at three questions, three similar questions that are asked in 3 states. Okay, so the first one is from Perlis, okay, Perlis 2020, and it is the graph. Okay, the velocity time and the displacement time seems to be a very popular question this year. Okay, but Perlis gives us a question that is talking about a displacement time graph. Okay, so displacement time graph, there's only one piece of information you need to know, which is the gradient of the displacement time graph is the velocity. Okay, and we study this in your maths modern. Okay, kamu punya maths yang bukan admaths lah, you also do this. So displacement time graph, when you calculate the gradient, you are also calculating the velocity. It's just a piece of information, not useful in this question today, but I just want to say it so that you know. Okay, so tick the correct answer in the box provided. Displacement is a vector quantity lah. What is the kawan to displacement, which is a scalar quantity? It is distance. Okay, so since we're talking about displacement, displacement is, the direction is very important. Okay, so what is the meaning of displacement? Okay, displacement is a distance, okay, in a certain direction. Okay, atau any other definition that is similar to it lah. Okay, I think for me the most important thing is that you must mention the word direction when you talk about displacement. Okay, because the direction is what differentiates it from a scalar quantity. Okay, so that's the important thing. Now, based on diagram 1, state the physical quantity represented by the gradient of the graph. This is a very common question, especially if it is question 1. Sure, they will ask one. Okay, so if it is a displacement time graph, the gradient of the graph will represent the velocity. Okay, state the time interval when it is stationary. Stationary means no, not moving lah. Okay, it is not moving, alias the velocity is 0. Otherwise, also known as the gradient is also 0. So the gradient is 0 is over here. Okay, so we will say 0 to 8 seconds. Okay, time interval. Okay, they are not asking for how long. Okay, dia bukan cakap how long. So since you are saying a time interval, you must have a start point and you must have an end point. Okay, so the weakness of a lot of students, kelemahan kebanyakan pelajar bila dia menjawab ini, dia akan jawab 8 seconds. 8 seconds, 8 saat. Okay, which is not the time interval. The 8 saat is how long it was stationary, berapa lama. Okay, we understand the question. The question is saying state the time interval, sela masa, dari bila sampai bila. That's the important thing. Okay, so you cannot how to say jangan pandang rendah tentang ini tau. It's easy but it's also equally easy for people to make mistakes, especially those yang selalu pandang rendah with these kind of questions. Okay, so be very very careful with this because tendency for students to make mistake here is always very high, and I think it's such a waste that because you did not read the question properly, you lose that 1 mark. Okay, so be very careful. All right, we see a similar question in Terengganu question number 1, but this time it is a velocity time graph. Okay, now let's go through the information we know. Now in a velocity time graph, okay, the gradient this time obviously doesn't represent the velocity lah. It represents the acceleration. Okay, and in the velocity time graph, there's an added thing which is the area. Okay, the area under the graph represents the distance. Okay, the area under the graph represents the distance. So, berbanding dengan displacement time just now, in a displacement time graph, there's only one quantity that you know, which is the gradient. In a displacement time graph, if you calculate the area, got no meaning. Okay, you're calculating nothing. Okay, kalau displacement time. But if it is a velocity time graph, okay, then there are two information you need to know. The gradient is the acceleration, and the distance is counted by calculating the area under the graph. Okay, so what is the meaning of velocity? Velocity is the rate of change of displacement. Okay, that's the standard one for velocity. And since we're talking about this, because we have the words rate of change, saya juga mau kita terus ulang kaji lah. Okay, acceleration. Acceleration is the rate of change of velocity. Okay, acceleration is the rate of change of velocity. Velocity is the rate of change of displacement. Okay, so based on this one, take the answer. So the car moves with constant acceleration from P to Q. Okay, P to Q, constant acceleration. Atau the car moves with zero acceleration at P to Q. Obviously, the answer will be this one lah. Okay, constant acceleration. Okay, kalau velocity time graph, constant acceleration will be like this. Okay, zero acceleration will be like this. The shape of the graph. Okay, so kalau constant deceleration, okay, means dia makin perlahan makan. The shape of the graph will look like this. Okay, kalau dia increasing acceleration, this is rare. Okay, ini jarang ditanya, but you should know lah. Okay, increasing acceleration, the graph will look like this. Okay, the curve up this way lah. Okay, and also the same thing, decreasing acceleration. They're accelerating, okay, but it's decreasing, so it will look like this. Okay, so but don't worry about the other two over there lah. Okay, just make sure that you know the this one, constant acceleration, zero acceleration, and constant deceleration. But remember, it is for a velocity time graph. You cannot make the displacement time and velocity time graph the same meaning. It totally different meaning. Okay, so jangan samakan. So yang saya kongsikan sekarang ini specifically for velocity time graph. Okay, velocity time graph, ingat saja, angkat tangan kanan, constant acceleration. Angkat tangan kiri, okay, is constant deceleration. the resting phase between your left hand and your right hand is zero acceleration here to here. Okay, so remember that. Right hand is constant acceleration, left hand is deceleration, resting phase. I don't want to say the word in between. I know what's the word in between, but resting phase, fine. Okay, the resting phase is zero acceleration. Okay, remember that. Okay, calculate the distance traveled by the toy car. The distance traveled by the toy car. Kalau dia adalah velocity time graph, you have to calculate the area under the graph. Hold on now. I'm getting this very, very annoying. Okay. Sorry. Okay, so the distance is calculated by the area under the graph. If you take a look at the graph altogether, it is a trapezium shape lah. Okay, so the total area on the graph is a trapezium shape. Trapezium will be 1 over 2, distance. Okay, distance is equals to area under the graph. So the area under the graph is 1 over 2. This point is 8. From here to here is 4. So 8 plus 4. And then the height over here will be 2. Okay, so you will get 12 meters. Make sure you have the value of the unit, okay, the unit of distance. Okay, hold on. There's an increasingly strange number of people here today because ada banyak orang yang baru macam first time saya jumpa. Okay, for those of you who are joining us for the first time, like I've never seen you at all before this kan, or baru hari ini kamu memilih untuk wujud, you have to know that I'm jumping from paper to paper because this is physics lah. I'm jumping from paper to paper, and secondly, you should also know that saya tidak menunggu. I don't wait for you to be ready lah. So be ready to jump in, at whatever paper. And it's okay if you want to tune out. It's okay because the video will be up on YouTube and you can watch it later to revise lah. Okay. But if you have any questions, you can always unmute yourself and just say excuse me, and then I'll listen to your question. Or you can type out your question in the chat section. Thirdly, if I make a mistake, and this has happened many, many times, okay, if you followed the sessions before this, this has happened many, many times, please point out the mistake to me, okay, because I'm only human and so are you. So, we help each other. All right, similar question, okay, also found in Putrajaya. Again, question 1. So we see 3 states coming up with this question for question 1. I'm not saying it's going to come out for SPM, but I'm saying that it's probably a good topic for you to revise. Okay, velocity time and displacement time graph. So as always, perhatikan now we are using velocity time graph. So remember the 2 pieces of information that you need in the velocity time graph. What does the gradient represent? What does the area under the graph represent? Then of course, remember your hands, the shape of the graph tells you a lot of things. So what is the meaning of velocity? Same thing as just now. The meaning of velocity is rate of change of displacement. Okay, so take the correct answer to be. So again, it's asking the words constant acceleration and zero acceleration. So we see this trend again and again. From P to Q, this is the resting phase. Resting phase is zero acceleration. Okay, so that's how we would go lah. Then again, the same question, calculate the distance traveled by the toy car. So you find that this shape once again is a trapezium. Down here is 10, up here is, let me see, 4 to 8. So 1, 2, 3, 4. Okay, and the height is 2. So the distance, okay, will be the area under the graph. Now you don't have to write this because it's not necessary lah, but I always write it because so that when people watch or when people see the working, they kind of know, oh, okay, this is what's happening lah. Okay, hold on. I think I lost connection with this one. Good job. Sorry, I'm going to pause video for a while. Okay, so distance is area under the graph, and as I said before, you don't have to write the words area under the graph lah. Okay, I just write it just to explain what's happening lah. But the area under the graph is 1/2 times 10 plus, how much was it just now? 4. Okay, 10 plus 4 times 2, so this will give you 14. And once again, don't forget the unit. Unit is meters. Okay, so just make sure you have that lah. How are the 2 marks given? 1 mark for penggantian betul. Okay, your substitution correct is 1 mark. Final answer with the unit is always another mark. Okay, so actually the words area under the graph, not necessary, but you know. All right, so that's one kind of question that is quite popularly asked, okay, in 3 states. Now, another type of question is a simple calculation questions taken from Malacca. Okay, Malacca question number 2, okay, is where we want to go next. Now, so diagram 2 shows a motor used to lift the load with mass of 8 kg. Okay, and then usually it is lifted up to a height and then in 4 seconds. So there's a lot of information over here. And usually, okay, so usually in a question that kalau soalan itu kan dia minta satu benda tu bergerak pada satu height tertentu bahkan. Okay, whenever you see the words height and this is kind of forces and motion, you kind of know that this has something to do with gravitational potential energy. Okay, potential energy. Okay, which is, forget the spelling, mgh lah. Okay, and because it is moving, dia mesti ada kaitan dengan kinetic energy. Okay, kinetic energy is 1/2 mv squared. Now on the flip side to that, there's also this thing about work. Okay, work is force times displacement. Okay, that's another thing lah. And then of course you want to have power. Okay, power is always energy over time. Because dia bagi masa pada sini. Okay, so whenever you see a question like this kan, have all these formulas in mind. Okay, I cannot guarantee that the formulas will be given at the start of the paper. Okay, but you should have that mindset lah. Okay, soalan ini kalau dia angkat barang naik ke atas kan, atau ada barang that is dropped. Okay, let's say an object that is suddenly dropped like that kan, usually has something to do with a change of energy. Okay, and this is chapter 2, and sometimes may have things to do with work. Okay, so state the type of energy that is gained by the load. Okay, at the position shown in diagram 2. This would be gravitational potential energy. Okay, kalau kau menjawab potential energy sahaja, saya rasa it's okay. My dog is acting up again. Okay, but it is good to add the words gravitational. Okay, it's because there are 2 kinds of potential energy. I know. One is elastic potential energy and one is gravitational potential energy. Yeah, sorry, I have to pretend to scold my dog while I'm talking to you all. Okay, so yeah, this is how I scold my dog. Okay. Work done, okay, by the motor to lift up the load. So, we kind of see this work, but actually, the work done, okay, and this is you can call this a hack lah if you want. The work done is actually the potential energy itself, okay, because the unit for work and energy is actually the same, it's joule. Kan? Yeah, it's joule. Gm2 S negative. Yeah, okay, it's joule. So when you want to calculate the work done, you just calculate the potential energy itself. So you can actually write work equals to mgh. Totally fine. Okay, so the load is 8 kg. Okay, 8 times our standard for G is 10. Okay, and then the height is 0.5 meters. Okay, and this will give you 40 joules. Okay, I don't know why I opened that calculator, but yeah, anyway. Okay, so yeah, so don't fall into the trap of always using W equals to Fs. You can use that, except that in this case, it is so much easier to count the gravitational potential energy because both are the same units. Okay, both of them are in joules. Okay, and so when you calculate the gravitational potential energy, it is actually the amount of work done to lift up the load. There is 0 joules until a certain height, and it takes about 40 joules. Okay, power is always energy over time or work over time. Okay, so the power is equals to 40 over, now how many seconds was it? 4 seconds. So 4 seconds, which will give you 10. The unit for power is the same. It is watt. Okay, watt, sorry, let's anglophile this now. Watt, 40J. Why, what's wrong with 40J? Not 40J, man? B1 is 40J, yeah. Isn't that what I wrote? Is this better? Oh, okay, yeah. Yes. Yeah, sorry. So yeah, my writing. Okay. All right. Now we see another question like this. Also question two from Penang. Okay, from Penang, and this is also kind of similar, except that, okay, I want you to take a look at how the question A is formed. In the previous question is state the type of energy gain. Okay, means apa yang dia perolehi. There's somebody outside my house. That's why my dog is very protective of this house for some reason. Shh. No need to minta kucing. Okay, so type of energy gain. So they only want one type of energy. But in this question, in Penang, Penang question number 2, they are asking for an energy change. So you have to go from one energy to another energy. Okay, so in the case of this bulldozer that is moving up a slope, it is got to be kinetic energy, okay, to gravitational potential energy. Gravitational potential energy. Okay, that will be how, because it's moving up lah. Okay, and then once it reaches up a certain height, it gains some kind of potential energy. Okay, so calculate the kinetic energy before moving up the slope. So the kinetic energy will be half mv squared. Okay, so half the mass, apa ini? The mass is 7,000 kg. Okay, and then the V, it is moving up with 35 meters per second. So it's pretty simple. Okay, 35 meters per, sorry. Why did I even write the unit? Okay, so half times 7,000 times 35 will give you 122,500. And don't forget the unit for energy is joule. Okay, so calculate the kinetic energy lah. Now, the speed of the bulldozer at R is 0. So this is a very important thing. Which means, this is an important thing. Kalau pada asalnya saya cakap all the kinetic energy is changed into gravitational potential energy, means that at the certain height, at the certain height, all the kinetic energy dari awal-awal sudah berubah. It has changed, it has been converted into gravitational potential energy. Okay, which means that the kinetic energy, equals to gravitational potential energy. I'm not going to waste time writing the whole thing. Okay, and I understand this because of these words. Speed of the bulldozer at R is 0, which means the kinetic energy is increasing and the potential energy is increasing. Okay, that's what it means. So we already counted the kinetic energy, 122,500. So all we have to do is count the gravitational potential energy, and we can have the height h in there lah. Kita mau cari h. Okay, so the mass is 7,000. Okay, sorry, mgh bahkan. Okay, so the mass 7,000, g is 10, and h is what we want to find. Okay, so we can use this now, 122,500 divide by 7,000, and then you divide again by 10. You get h equals to 1.75. The unit for height is always meters. Okay. This is a common question. Sorry, I just need to say this. Common question in paper one. Conversion of energy. Kinetic become gravitational. Gravitational become kinetic. Okay, it's a very commonly asked question in paper one. Okay, at least one question will sure ask one. And obviously in paper two, this seems to be a popular question as well. Okay, so that's why I want to cover all these basic formulas with you so that you don't forget lah. Okay, and in case lah, okay, kalau in case dia tanya what is the principle behind this? Kenapa kamu boleh cakap kinetic energy equals to gravitational potential energy? Is because we're talking about the principle of conservation of energy. Okay, bukan momentum. Not talking about momentum. Momentum is a question that came out 2 years ago, I think. Okay, but this one, kinetic energy equals to gravitational potential energy. It comes from the principle of conservation of energy. Okay, one form of energy fully convert into another form. Okay, so all the energy is conserved. Okay, so in case lah, okay, in case this ini sesi ulang kaji jugalah selain daripada menjawab soalan. Okay, a similar question that has something to do with what we were discussing just now is question number 11 from Perlis. Okay, I'm going to give you some time to look for it because I also need some time to look for the answer. Hold on now. Perlis question number 11. I should have. I should have arranged my papers much earlier. What a thing. Okay, Perlis question number 11. I'm getting this right. Okay, so distance 11.1 shows the national speed limit, okay, which is 90, and the load limit for federal roads in Malaysia. Load limit is usually for trucks, for lorries and trucks. So you have BDM at 4,800 and BTM at 2,370. So what is meant by speed? Now, just now, when we were doing velocity, what is meant by velocity? We were saying that velocity is the rate of change of displacement because it is a scale, it's a vector quantity. Okay, but now we're talking about speed. Okay, this question, okay, in Perlis 2020 is asking for speed. So speed is the rate of change, not of displacement, okay, but of distance. Okay, sebab speed and distance are both scalar. Velocity and speed and distance are both scalar. Velocity and displacement are both vector quantity. So be very, very, very careful with this. Okay, so kalau speed dia minta is rate of change of distance. Now, using the concepts of momentum and inertia, explain why the speed limit and load limit must be imposed. Why must there be a speed limit? Okay, and why must there be a load limit? Okay, so since they are asking us to explain in terms of two concepts, and this is a 4-mark question, we assume that 2 marks for momentum and 2 marks for inertia. Okay, so we can put it in this way lah. Point number 1 will be momentum depends on velocity and mass. Okay, the bigger the velocity, the bigger the momentum. Okay, so there has to be a speed limit. Okay, so that you know your momentum doesn't get too big lah. Okay, 3. Okay, inertia depends on inertia only depends on one thing, which is mass. Okay, and then point number 4, the bigger the mass, the bigger the velocity. Sorry. Sorry. What am I saying? Oh no. This is why I don't like to have class in the afternoon, because I'm so the bigger the mass, the bigger the inertia. Okay. Now, but this still doesn't explain now why there has to be a speed limit. Lah. Sorry, I'm going to give 5 points for this. Lah. Okay, a speed and load limit, okay, is necessary to control moving vehicles. Yeah, okay, to a speed and load limit is to vehicles that have mass and velocity. Okay, so you're using momentum and inertia to explain this. So you want to control the moving vehicles. Okay, you don't want them to, uh, you know, you want them to be able to easily stop. Okay, when it's time to stop lah. You don't want it to tekan brake and then it's still going on and all the way then. So we need to have that kind of limit. Okay, a certain speed limit. You cannot move faster than this, and there has to be a load limit. They cannot be heavier than this. Okay, so that it's easy to control these moving vehicles. Okay, in this mass and velocity lah. Okay, I know it is a 4-mark question, and I gave 5 points. Okay, but sometimes it's better to override. Okay, especially if you know that saya punya penjelasan ni tidak cukup ini. Okay, I can still write some more. Go ahead, write more. Okay, then usually the examiners what they will do is they will compensate lah. They will still try to look for the 4 marks. Okay, so don't worry about it. Right, table 11.3 shows 4 tankers, K, L, M, and N with different specifications. Okay, you are required to determine the most suitable tanker to deliver highly flammable fuel, okay, safely. So that's our this one. Okay, that's our this one, and okay, the last one is this one. So this one we know lah. Okay, this is a 10-mark question, and if you have followed the videos before this, you know that we always analyze the table first, then we answer. Okay, so let's talk in terms of the tanks. You want to have 1 big tank or 5 small tanks? Obviously, you want to have 5 small tanks. Okay, and the reason for this would be to reduce the negative impact of inertia. Okay, that's a good answer lah. Reduce the negative impact of inertia. Number of tires. Now, you are given 4 or 8, okay? But in your answer, you don't write 4 or you don't write 8. Remember, never write the numbers. Okay, you always say more tires. Okay, obviously we want more tires lah. Okay, more tires, and the reason would be to reduce pressure. Okay, on the road. If there's less tires, there's smaller surface area. Smaller surface area means higher pressure, which is not good for the road lah. Okay, itu yang bikin pothole tu sebenarnya. So when they have more tires, okay, more tires, so you less pressure on the road because the petrol is heavy lah. Okay, the gas that the tanker is carrying is heavy. Okay, and if there's a lot of pressure on the road, it causes the road to have potholes. Okay, so itu yang sangat jauh lah. Keep it a little bit nearer to ground. We just say reduce the pressure on the road. Okay, the brake system. Do we want air brake or do we want anti-lock brake? Obviously, we want anti-lock brake lah. Okay, anti-lock brake, and the reason for this is to avoid. Simple reason is to avoid skidding. Okay, I will talk about ABS in a little bit more, maybe in another question. But for now, let's just keep it as simple first now. Okay, avoid skidding. Okay, the distance of the tanker head and the tank. Okay, now in case you don't know what's the tanker head, this is obviously the tank. Okay, this is the tanker head lah. Okay, so we want the distance to be long. Okay, we want the distance to be long, so that it can be over here. It says to increase the time of impact, to decrease. What's the kawan? This always dia Upin dan Ipin. Increase the time impact to decrease what? To decrease impulsive force. Okay, ini selalu mesti segerombolan. It must go hand in hand. You cannot separate the two. Okay, increase time impact to decrease the impulsive force. You can also say that the distance between the tanker head and the tanker is to ensure the driver's safety. Okay, to protect the driver. Also can. Okay, it's a good answer also, but this is a better answer. It's a more physics answer. Okay, so obviously after you've done the analysis of the table, you see that tanker M is the best lah. Okay, because it has 5 small tanks, it has more number of tires, it has anti-lock brakes, and it has a long distance between the tanker head and the tank. Okay, actually, I just want to say this lah. Okay, I know that just now I said kalau dalam case the number of tires kan, okay, I said don't put in the number, say more or less makan. Actually, you should also do the same with the tank. More small tanks. Okay, but since over here kan, the focus is not on the number 1 or the number 5 lah. The focus is on the small or the big tanks. Okay, so it's okay if you still write the number 5. Tapi kalau number of tires kan, avoid writing the number 8. Write more tires. Okay, that's how you would answer the question. Okay, tanker of mass yada yada accelerates from yada yada. So calculate the acceleration of the tanker. Okay, so you are given the mass is 4,800 kg. Since it is moving from rest, okay, U will be equals to 0. And I'm going to use kilometers per hour since everything is in kilometers per hour. So V will be 90 kilometers per hour, but unfortunately our time is in 10 seconds. Don't you just love these kind of questions? Okay, so how do we change 90 kilometers per hour into meters per second? We have to change it to meters per second. So sad. Okay, so in the past, I would have told you that it will be 90 times 1000 to change from kilometer to meter, and then divide by 60, and then divide by 60 another time lah, to change from hours to seconds. Okay, but now we don't have the time to do that. Okay, so how to change from kilometer to per hour to meters per second? Hold on. Okay, you just multiply by 5 over 18. Yeah. Okay, I'm just going to like give you this short hack lah. Okay, kilometer to hour change to meters per second, just multiply by 5 over 18. Okay, because this 1000 divided by this one is 5 over 18. Okay, but yeah. So change from meters per second to kilometers per hour is divide by 5 over 18. Tapi ini jarang berlaku lah. Usually it's always change from kilometer per hour to 5 to meters per second. Now in normal circumstances, I don't teach like this. I will teach you properly lah. Okay, multiply by 1000, divide by 60, divide by 60. But because we're so near to exam time, we got no time to remember all this. If you can remember this, just remember this. Okay, kilometers per hour change to meters per second is just multiply by 5 over 18. Okay, and you will get 25 meters per second. So I can calculate the acceleration, V minus U over T. 25 minus 0 over 10 seconds. Okay, it will be 2.5 meters per second squared. Okay, that's how I will answer question A. Okay. Question B will be calculate the force. Force is mass times acceleration. Okay, the mass is 4,800 kilograms. Acceleration you've calculated is 2.5, so you get 12,000 newtons. Okay, so the difficult part about this question is not so much that it is difficult, but it is that you are given the velocity in 90 kilometers per hour. Okay, so when you have 90 kilometers per hour, make sure you change it to meters per second. How do you change it? Darab dengan 5/18. How are you going to remember this 5/18? Oh, I don't know. Somebody's birthday is on the 18th of May lah. If you can remember somebody's birthday, that's how you remember this lah. Okay, another question, and since we've already started talking about this, we need to start talking about impulsive force and impulse, because this seems to be another subtopic that is very popular, in forces and motion. Impulsive force and impulse. So diagram 6.1 shows an athlete in conducting a high jump. Okay, diagram 6.2 shows the same athlete jumping at a higher height. Okay, 6.1 is more realistic lah. Look at 6.2 lah. Come on lah. Okay, 6.2 is so unrealistic lah. I don't know anybody that jumps that high lah. Okay, but anyway, the diagram is just meant to help us, not meant to show the real deal. Okay, what is meant by impulse? Impulse is the change in momentum. Okay, you know what? I'm going to change it to change of momentum. Okay, so formula, okay, there is a given formula. Okay, impulse is actually mv minus mu atau force times time. Okay, force, then you darab dengan time, you get impulse also lah. But the official definition is the change in momentum, because it's mv minus mu. Okay, explain how the mattress laid prevent the athlete from severe injuries. This is a 2-mark question. Okay, sorry, this is from Negeri Sembilan. This is a 2-mark question, so I don't want you to waste it. We kind of know that because this has impulse and impulsive force, so you kind of know that the mattress, okay, the mattress, what does it do? Okay, the mattress extends the time of impact. Okay, to, what is the segerombolan dengan dia? To decrease the impulsive force. Okay, 1 mark, 1 mark. Let me just check the schema to make sure that this is the correct 2 marks. What is this? Negeri Sembilan. Negeri Sembilan. Hold on. Negeri Sembilan is the one with the... What happens when you have too many marking schemes? So you kind of lost yourself. You know where I'm. There we are. Okay. Question number 6. Yeah. Okay. To extend or to increase the time of impact. Yeah. Sorry. If I teach you, then you would know that the word I always use is to increase lah. Okay. To increase the time of impact so that you decrease the impulsive force. They always go hand in hand. That's why it's always 2 marks. Okay. Now, observe 6.1 and 6.2, compare the mass of the athlete. Since it is the same athlete, so 6.1 and 6.2 must be the same. Okay, and I've said this in all the past 3 videos for physics, and I'm going to say it again. 6.1 equals to 6.2. If you give this kind of answer, it is not correct. Okay, make sure you write full sentence. I'm just giving you the lazy answer for now because we're just ulang kajiing. Mengulang kaji. Okay, so the height of the high jump bar, 6.1 is smaller than 6.2. Otherwise, 6.2 is bigger than 6.1. Either way also can. Okay, the final velocity of the athlete before landing on the mattress. Now take a look logically. This guy jumps over. Okay, obviously the velocity is going to be smaller. Since this guy has a higher place to cover, obviously the final velocity ngam-ngam sebelum dilandingkan dia akan lebih tinggi. So 6.2 will have a bigger velocity than 6.1. Okay, looks like it's going to rain. Okay, based on your answer, state the relationship between the height of the high jump bar and the final velocity. Okay, 6.2 bigger than 6.1, 6.2 bigger than 6.1. Therefore, the the bigger, okay, the height of the high jump bar, okay, the bigger the final velocity. Okay, and once again, I'm going to remind all of you for the don't know how many of time. Okay, dan saya rasa ada di antara kamu pun tahu sudah ni apa yang saya akan ingatkan kamu. Please use the words bigger, smaller, higher, lower, greater, lesser. Okay, don't use the words the faster, the final velocity. Oh, no, no, no. Okay, no, please, for the love of God, don't. The faster the final velocity, no. Okay, it's a weak answer. Okay, written by only weak students. So please don't. Saya kecam sudah ini. Okay, because saya sudah bagi tahu banyak kali. Jangan tulis begitu. Okay. Yes, thank you. The halal words. 4287500. Okay, sorry, somebody just asked me a question. Penang. Penang. Did I not give this correct? Oh yeah, sorry. This is wrong. Okay, sorry, my so sorry. Okay, thank you for pointing out this one. I just saw the chat just now. This is MV squared. So actually I calculated the thing wrongly, my bad. 7,000 times 35 times 35 is, thank you for pointing this out, is 87500. 87500. That means over here also I'm getting this wrong. Okay. 4287500. Okay, thank you for pointing out the mistake. See, I told you I'm human. Okay, so the height will be 61.25 meters. My bad. Okay, so the Penang question just now, okay, question number 2, I calculated this wrongly because I forgot to square the 35. Okay, so the actual kinetic energy is this 4287500. Okay, and then the speed is the way to calculate is still the same, cuma saya salah calculate lah. So you get 61.25 meters. Okay, thanks for pointing it out. Okay, so coming back to this, yeah, please remember, don't use the words faster, velocity. Okay, higher, lower, greater, smaller, bigger. Okay, that's what we use. So finally, state the relationship between final velocity and impulse. So the bigger the final velocity, okay, the bigger the impulse. Okay, and also just as a reminder, I've mentioned this also lah before. Whenever you're writing a relationship, always pause for a while to think about whether it makes sense. What affects what? Okay, so the final velocity affects the impulse, correct. Impulse affects the velocity is wrong. So you cannot write the bigger the impulse, the bigger the final velocity. It's not correct. Okay, the final velocity determines the impulse. Okay, so be very, very careful with this. Just kebetulan bahawa in this question, they already give you the correct order lah. Okay, final velocity comes first, then impulse. But not every question is like that. Okay, so be very careful. Always make sure your brains are turned on, okay, when you are writing a relationship. Okay, super, super important. Okay, all right. Let's move on. Also, a similar question, impulsive force, asked in question 11 of Malacca. Okay, so this is Malacca 2020, question number 11. Okay, and it is still asking the same words, impulsive force. So just now we said impulse. Impulse is change of momentum. So the impulsive force, okay, is the rate of change, okay, of momentum. Okay, so today we have seen three definitions that involve rate. Okay, velocity, acceleration, and impulsive force. All three is rate of change of apa. Okay, itu je yang kau kena berubah. Okay, so it's good to have these definitions because it's simple definitions. The words are the same, cuma the last word saja yang berlainan. Okay, kalau velocity is displacement, kalau acceleration is velocity, kalau impulsive force is momentum. Okay, the things that never change is ROTO, rate of ROCO, rate of change of. Okay, so don't take out the rocho lah, ROCO. Explain why the bikers must wear helmet, gloves, and jacket in a race. Okay, for those of you who are just joining, we are at Malacca 2020, question number 11. Explain why the bikers must wear the helmet, gloves, and jacket in the race. Now, you kind of know that because we're talking about impulsive force, okay, the helmet, the gloves, and the jacket, okay, are all actually serve the same function. Okay, so point number one. Oh no, I got no space. Okay, fine. Point number one, always the same segerombolan. Okay, to increase the time of impact. Okay, point number two, to reduce the or to decrease the impulsive force. Okay, number three, the helmet. You can talk about the helmet lah. Okay, helmet is to protect the head. Manakala, question number four, the jacket and the gloves, okay, which is about the same. Obviously, it's not to protect the head. Okay, you don't wear jacket to protect the head. Okay, you wear the jacket to protect the body. Although from this picture, actually it looks like the jacket is used to protect yourself from the dust lah. Okay, but the jacket actually has padding. They're quite tebal lah. Okay, so it's actually to protect the body. And how does it protect the body? It increases the time of impact so that it reduces the impulsive force. Okay, that's how we will get the 4 marks. All right, racing motorcycle of mass 200 kg. Once again, now we see the kilometers per hour over here. Okay, you remember how to change kilometer per hour because the first question is this. Calculate the maximum velocity in SI unit. This is a 1 mark question. So no matter what you use, whether you use the long way or the short way, you will still get the same answer. Okay, 160 multiplied by 5 over 18. Okay, you will get 44.44 meters per second. Let me just double check. Okay, 44.44 meters per second. So calculate the acceleration. This is the exact same question as the one that we saw just now because it starts from rest. Rest means u equals to 0. This is v. So acceleration is v minus u over t. So 44.44 minus 0 over 10 equals to 4.444 meters per second squared. Don't forget to write the unit. And then the same question as just now lah, calculate the force. Force equals to MA. Okay, obviously the M is 202, so 202 times 4.444, you get 896.888 newtons. Actually it's 988 ka. 202 times 4.444. 897.688, see? 202 bahkan, yeah. Okay, 897.688. Okay, 688 newtons. Okay, obviously the most important thing is make sure that even if you are answering the numerical values, make sure that your unit is correct. Okay, so the unit is very important now. Okay, so see the pattern now. Okay, previous question we had the same question. Okay, except that in this question from Malacca, they are more helpful. No, they actually tell you to change the kilometer per hour to meters per second. Just now, the question that we answered, this one, which is from Perlis, okay, they didn't even tell you to change the kilometer per hour, tukar pergi meters per second. Okay, so be very careful with this unit stuff lah. Okay, always change it to SI unit. Meters per second is meters per second. Okay, so I hope that the 5/18 is helpful for you lah. It's a shortcut, okay, because at this stage of your studying life, changing from kilometer per hour to meters per second is actually a Form 1 maths question. Okay, you are not even supposed to be like, macam mana mau tukar itu Okay, no, that's a Form 1 maths question. So you actually should have known this by now. So we just use the shortcut, totally works. So it doesn't matter. You just have to remember what the shortcut is lah. Okay, I cannot help you if you don't remember the shortcut. Okay, diagram 11.3 shows 4 racing motorcycles, PQRS, with different specifications. Okay, so take a look. Okay, obviously it looks like the 4 specifications are the type of brake, the mass, the seat height, and the width of the tire. Looks like it lah. Okay, what do we want to do with this? Study the specifications, determine the most suitable racing motorcycle to move fast and safe. So we want it to be fast and safe. Okay, let's take a look. Type of brake, without ABS or with ABS. Obviously, we want with ABS lah. Ini yang kita mau. Okay, the reason for this would be to avoid skidding. Okay, is a good answer. Another one, since you're talking about motorcycle, okay, another reason could be that it's easy to control when changing direction. Okay, so because you know when you have a racing motorcycle, you're always changing direction. So you always have to press the brakes. So you want to be able to control easily when changing the direction. And that happens with the ABS system. You don't want the wheels, the tire, then suddenly berhenti. Okay, it's the worst thing that can happen. So that's not good. Okay, second one is you want the mass. Okay, 205 kg, 220, 208, or 242. We are talking about smaller mass. Obviously, we don't want to have a certain number. We want to have a range. So we're thinking of small mass, okay, in the 200s. Okay, small mass is usually equated with lighter. Okay, lighter, or you can even say low inertia, easy to start or to stop. Okay, that would be the mass. Okay, seat height. You have 4 different choices, 905, 1010, 815, and 1055. So it's either higher seat height or lower seat height. Okay, think about racing motorcycles. We usually want lower seat height. Okay, low height. Okay, low height usually is, their punya reasoning is low center of gravity. Why is low center of gravity important? You can also say increase stability. They're more stable lah. Okay, nobody wants to ride a motorbike dengan kamu punya pantat tertongking ke atas. It doesn't work. Come on. Okay, it's just minta puji saja. Tapi it's like you. Okay, it's not fast. Okay, width of the tire. So you have 1440, 940, 1440, or 940. So you obviously want a big width of tire lah. Okay, big width of tire. So we have this. So the big width of tire will be bigger surface area. Bigger surface area means low pressure. Okay, low pressure, or you can also say more friction. Okay, or you can also say better support. Because the tires are bigger. Okay, I've never seen a racing motorcycle kan yang menggunakan tayar basikal. Okay, I've never seen that. Okay, but I always see a lot of bicycles that use tire motor. Have you seen it before? It's very interesting. Because anyway, the best racing motorcycle will be motorcycle R lah, cause they are the all the chiri-chiri, the suburb. Okay, all right. Uh, it's 3 o'clock. I'm going to take a short 5 minute break because I need to drink water. Okay, when we come back, we're going to go into the last topic, the last subtopic for chapter 2, and then we're going to move on to the experiment questions. Okay, so I'll see you in 2 to 3 minutes. All right, welcome back. So let's continue to the last subtopic, which actually I have left the heaviest one to the last. Sebelum ini, it's not very popular. If you notice, I've only answered 2 section B and section C questions so far. But this seems to be quite a popular topic for this year, okay, which is Hooke's Law. Okay, Hooke's Law is the one with the spring and it's the one with the elastic potential energy. Okay, let's talk about that first. So the formula that is involved, okay, in Hooke's law is F equals to Kx lah. Okay, K is the spring constant. Okay, and X is the extension. Okay, dia punya pemanjangan atau pemendekan selepas kamu letak beban. After you put on the load, how much it extends, okay, is the extension. And you please take note that it has to be written in meters. Okay, the extension cannot be written in centimeters. Okay, another formula that is associated with Hooke's law is elastic potential energy. Okay, so the elastic potential energy is 1/2 Fx or 1/2 Kx squared. Okay, so it depends on which one you want to use lah. Okay, depends on what they give lah. Okay, but I just want to say that this is the formula involved. I don't think we're really going to be talking about the formula here, but we'll see how lah. Okay, so you have a load of mass 1 kg, spring M, okay, on one spring. Hooke's law, okay. Now Hooke's law is how to say the extension, okay, extension on spring is directly proportional. Did I just say directly? Directly proportional to its load. Okay, that is Hooke's law, except that in Hooke's law, there is actually a condition. Ada syarat itu sebenarnya. Okay, let me look for this one, just to make sure that I don't get the words wrong. What question is this? Question number 7. I'm getting very tired of all this. So many papers. Question number 7. Okay. To its load atau to its force. Okay, but there is a condition. Okay, the condition is if the spring is I got no more space already, sorry. Okay. Okay. The extension on the spring is directly proportional to its load or to the force if the spring is not stretched beyond the elastic limit. Okay, now I want to highlight this because the words in blue is the one that is orang selalu hafal. Okay, but the problem with Hooke's law is there is a condition. The words in green must be included, okay, in order for it to be a complete definition. Okay, it is only directly proportional selagi spring itu masih kenyal, as long as it is elastic. Elastic means you take out the load, it can go back to its original position. Dia bukan menjadi loose sudah lah, okay? It doesn't become loose after you, because you know sometimes the spring after you overstretch it, it becomes loose. When it becomes loose, then you have made it go beyond the elastic limit. Dia sudah melebihi had kenyang. Okay, so that is the condition for Hooke's law. The spring must not be stretched beyond the elastic limit. Okay, then it is directly proportional. Okay, calculate the spring constant of M when the extension is 4 cm. Okay, so the first thing we need to do is change the 4 cm to 4 to meters lah, which is 0.04 meters. Now, since the load is 1 kg, so we know that the force is 10 newtons lah. Okay, multiplied by 10. So the formula is F equals to Kx. Dia suruh kita kira K. Okay, so 10 equals to K times 0.04. So K will be 250 Newton per meter. Okay, the unit for the spring constant is Newton per meter. Okay, so spring M breaks when it is hung with a heavier load of 3 kg mass. So you have put a 3 kg mass and then the spring will break lah. Okay, so suggest a modification that can be made to the following aspects to be able for the spring to withstand a heavier load. So the stiffness of the spring must be increased. Okay, kasih keras lagi to spring lah. Okay, so the reason will be high spring constant. Okay, or you can also say it can withstand a big force lah. These are the better answers. Okay, high spring constant. When you increase the stiffness, you increase the spring constant. When you increase the spring constant, it is able to tahan a heavier weight. Okay, it is able to tahan a heavier weight, which is this one lah, big force. Okay, the thickness of the wire should be higher. Okay, or you can say increase the thickness lah, also can lah. Okay, you can also give the same reason. Okay, so that the spring constant is high so that you can withstand big force. Okay, is it okay to put the same reason for another question? Totally fine, no problem. But the reason must make sense lah. Okay, don't say thickness of the wire should be higher because it's lighter. No, doesn't make sense. Okay, you can say high spring constant, you can say withstand big force, no problem. Okay, the type of material you should suggest, since they want type, okay, you suggest a certain type. Of course, the best would be steel. Steel springs are generally hard. Okay, so you can say steel is stronger. Or you can even cheat again and say withstand big force. Buyuk, betul kan? Either way also can lah. Okay, so all this, when you increase the stiffness, when you increase the thickness of the wire, when you change the material to spring, actually all that you're doing is you are increasing the spring constant. Okay, because as I said just now, when you increase the spring constant, you are increasing the ability for it to bertahan dengan daya yang atau berat yang lebih tinggi. Okay, itu sebenarnya yang penting. So identical spring N is hung together with M. Draw the arrangement of the springs that can hang a heavier load without breaking the springs. So obviously you want to have a parallel arrangement. Okay, so this is how I would draw it. They ask you to draw lah, okay? But if they ask you to nyatakan, let's say state the arrangement, then you say it is a parallel arrangement. Okay, parallel arrangement boleh menahan beban yang lebih berat tanpa pecah. Okay, kalau series arrangement like this is one spring and then bersambung lagi dengan spring yang lain kan. This is more for bungee jumping lah. Okay, so you want it to elongate. Kamu mau dia punya extension bertambah. Okay, totally different reason altogether. Okay, but in a series extension, in a series arrangement, okay, it's better for bungee jumper lah. Okay, I mean, if you have ever seen a bungee jump video, kan, you only see one long tali, bahkan you don't see like 5 tali on one person. Okay, like parallel arrangement together lah. Okay, because we want that toing effect. Okay, so if you want a bigger toing effect, then we use a series arrangement. But if you want it to stay without, breaking, or if you need to be more stable, use a parallel arrangement. Okay, another similar question is asked in Kelantan, okay, for Hooke's law. Okay, so now we're going into the actual section B, section C questions, because I think 2 or 3 states have the same subtopic, which is Hooke's law, okay, which is why I want to discuss this a lot. So diagram 9.1 shows 2 springs A and B of the same length, made of the same material, but of different thickness and spring constant. Okay, experiencing extension when load of the load is the same, 200 grams. Okay, what is the spring constant? The spring constant definition is force per unit extension. Okay, let me just double check. It should be force per unit extension. Kelantan. Kelantan, where are you? So, yeah. Okay, force per unit extension. Okay, that's the definition of spring constant. Compare the thickness of the spring's wire extension and the force. So the thickness will be, we have to use spring A and spring B lah. Okay, so A is bigger than B. Extension of the spring, B is bigger than A. Okay, and the force is the same because both have the same load. Okay, dia punya beban adalah sama, 200 grams. Okay, so the force is the same. So relate the thickness of the spring with the extension of the spring. So the bigger the thickness, okay, the bigger the thickness, the smaller and the extension. Okay. Oh, okay. Sorry, extension is smaller. Okay, the bigger the thickness of the spring, the smaller the extension of the spring. To make a deduction regarding the relationship between spring constant and the thickness of the spring. Okay, so the same thing, the bigger the thickness of the spring, the bigger the constant. Yeah, okay. Spring constant is bigger. Sorry, I'm just giving the lazy answers because I really want to go into the experiment question soon. And I realized that I only have 45 minutes left. Okay, so this is a very straightforward compare and relate question lah. Okay, so kalau kamu sudah banyak buat latihan, should be no problem. Okay, diagram 9.2 shows a force F against extension X graph of 2 different springs. Okay, same length P and Q, but look at this one. So determine which spring has the bigger elastic potential energy and spring constant. Obviously, it will be spring Q. Okay, because in an fx graph, okay, let me explain this lah. Saya terus bagi jawapan untuk ini ya. Why is it that spring Q has a bigger elastic potential energy and a bigger spring constant? Okay, because point number 1, okay, the spring constant, sorry, the gradient of the graph, okay, represents spring constant. Secondly, the area under the graph represents elastic potential energy. Okay, sorry. So the gradient of the graph represents the spring constant. So since P is much higher than, Q is much higher than P, obviously Q has a bigger spring constant because the gradient is bigger. Secondly, look at the area under the graph. Look at Q's area and look at P's area. Obviously, Q has a bigger potential energy because the area under the graph is much bigger. Okay, so that's 2 marks over there. And then lastly, state the relationship between elastic potential energy and spring constant. Such a bonus, kan? Okay, so the bigger the elastic potential energy, this is terbalik. It should be terbalik. spring constant must come first. Okay, the bigger the spring constant, okay, the bigger the elastic potential energy. Yeah, because the spring constant is the one yang mempengaruhi, the one that affects the elastic potential energy. So spring constant must come first. Okay, be very careful. As I said just now, when you write a relationship, turn on your brain. Okay, make sure that the relationship makes sense. Okay, that's how you get the 3 marks. So here 1 mark, and then these two is 1 mark, 1 mark. Okay, these are all facts. Okay, please remember this. Okay, diagram 9.3 shows a spring toy gun. So the toy gun is unable to shoot a far distant target. Okay, dia tidak boleh tembak jauh. Okay, so suggest modifications that can be made to the structure of the toy gun to enable the ball bearing to go further and hit the target more accurate. Kamu mau dia lebih accurate dan kamu mau dia pergi dengan lebih jauh. Now, state and explain the suggestions based on the characteristics of the spring and the ball bearing and the method to aim the target. So they only give 3 characteristics. But obviously, by now, I hope that you know that you need to have at least 5 points. Okay, so let's talk about the spring first. So you can actually mention the same points as we talked about in the previous question. Remember this question? Same points. How is the thing, how is the spring, how is the ball going to be able to go further? You need to have a spring with a bigger spring constant. Okay, so that will be point number 1. How do you get the bigger spring constant? Okay, so the thickness of the wire. Okay, increase the thickness of the wire. Okay, secondly, you increase the diameter of spring. Okay, this is another one. Increase the diameter of the spring, increase the thickness of the wire. What is another one? Let me see. Oh, okay, sorry. The third one is use a more elastic spring. Okay, use a more elastic spring. Now, these two, the reason, okay, I'm going to write the reason in blue, okay, higher spring constant lah. Okay. Um, okay, higher spring constant. This one will be easy to compress. Okay, since it's more elastic, it's easier to compress, therefore it will be able to shoot the ball bearing a lot further. So the first 3 points, okay, are berkaitan dengan the characteristics of the spring. Okay, now we need to talk about the ball bearing. Okay, what characteristics of the ball bearing should be? The ball bearing, okay, should have low mass. This one is the only characteristic that matters. Your ball bearing is generally quite heavy lah, okay. So you need to have a ball bearing with small mass, okay. Dia lighter, tapi dia bukan seringan bulu ayam lah, okay. You want it to be light but still strong, okay. So small mass means lighter lah. Okay, and then lastly is the method to aim the target. So how do you aim? Okay, kalau the tempat yang kamu mau tembak is here kan, you don't aim directly because you're coming from so far away. So you aim a little bit higher. Because bila kau sudah mula tembak, the ball bearing is going to travel and gravity is going to pull it down. So you don't aim straight macam ni. Because what happens is bila kamu tembak, the ball bearing is going to be ditarik oleh gravity. Okay, so you aim a little higher. Okay, then the target. Okay, and then the reason will be gravity will pull the ball bearing. I have seen another answer. This is to compensate for gravity lah, tapi it's very high class lah the answer. Okay, it's a good answer, but a little bit incomplete lah. Okay, this is a better answer. Gravity will pull the ball bearing uh, downwards lah. You can actually write the word downwards. That's why you need to aim a little bit higher. Okay, aim a little bit higher so that you will actually kena do this one. If you aim ngam straight kan, okay, unless you're very near lah, okay, then obviously you aim straight is makes sense. But you are now kamu menembak dari jauh bah, so you need to aim a little bit higher and let gravity do its magic. Wow, I still got one more. Okay, come. So this is from Terengganu, question number 11. Also another Hooke's law question. So notice that this Hooke's law is coming up a lot. Okay, I have spent almost half an hour talking about Hooke's law. So figure 11.1 shows a ball of mass 0.01 kg, compressed electric spring. Spring constant is given 200 Newton per meter. Initial length is 0.2. Now what is the meaning of elasticity? Elasticity. What is this? This Terengganu. Elasticity is the ability for an object to return to its original state right after the load has been lifted. Isn't that how it is? Question number 11. Yeah, okay. So elasticity is the ability of an object to return to its original state when a load is removed. Okay, an ability of an object to return to its original state after you move the load, dia akan kembali kepada keadaan asal. Okay, so explain why the spring is elastic. Okay, fine. Let's do this. So why the spring is elastic is because we have to talk about this at the molecular level. Okay, so point number 1. Okay, the molecules in the spring, okay, have attraction and repulsion force. Okay, so the molecules in the spring, okay, they are attracting and repelling at the same time. Okay, they're always attracting and repelling. Okay, number 2, when the spring is stretched, the molecules move further apart. Okay, point number 3. Okay, so since the molecules are moving further apart, okay, and molecules are basically just like us humans lah. Kita tidak suka perubahan. We don't like change. Molecules also work the same way. When you try to pull the spring, the molecules akan berasa berjauhan. So diorang tidak suka. And what do? They turn on their attractive force. Okay, so the attraction lah. Okay, fine. The attraction force, daya tarikan, okay, between molecules increases. Okay, and then the 4th and the 5th point is the terbalik of the 2nd and the 3rd point. Okay, the 4th and the 5th point. 4th is when the spring is compressed. Okay, I'm going to just change the words, give you the keywords. When the spring is compressed, bila spring itu dimampatkan, the molecules move nearer to one another. Dia akan lebih dekat. Okay, and molecules, again, just like humans, we don't like change. Kita suka benda, just the way it is. Why do things have to change? Sounds like a life lesson here, kan? Yeah. Okay, and what do the molecules do? No, don't come near me. So the repulsion force, okay, daya tolakkan, okay, repulsion force between the molecules increases. That's why it is elastic. Itulah sebabnya the spring boleh kembali kepada keadaan asal. When you remove the load, okay, dia masih lagi menolak atau dia masih lagi menarik. Okay, and that's why it can go back to uh, the original state. Okay, so and if you think about it, okay, sorry, I'm going to digress a little bit. If you think about it, the spring kind of works in the same way as Lenz's law. Kan? You want to put the north magnet nearby kan, terus the magnet jadi north. Okay, so dia tidak mau. I don't like this change. Okay, when you move the magnet away, the solenoid will do everything to attract the magnet back. Okay, because don't want the magnet to move away, doesn't like change. Molecules work around the same principle as well, and so do humans. Okay, think about our MCO now. Okay, I'm going to go into the moral talk lah. Okay, think about the MCO now. Nobody likes this change. Okay, nobody likes this change. But what do? Okay, we work and we try to get our lives back into the normalcy. Okay, we all want for things to go back to normal. Okay, so what can we do? We can support one another, just like the molecules in the spring. Okay, support one another. You either attract one another to each other or you repel one another. Make sure you support one another. Okay, in this very, very difficult time. Okay, it's almost over, people. Okay, don't worry about it. Okay, so diagram, this one shows the spring compressed by 0.1 meters. Good news, it is already in meters, so don't bother changing it to this one. So calculate the elastic potential energy at the spring. Elastic potential energy is 1 over 2. You can either have kx, okay, if you remember, kx squared, or 1 over 2 fx. Let's take a look. What is given? It is given, you are already given the 200 spring constant. So 1 over 2, 200. What is the extension? Originally is 0.2 meters. Then you decrease to 0.1. So the extension is 0.1. Be very careful, it is 0.1 squared. Okay, so you will get 1 joule. Maximum velocity. Now, after the compressive force is removed, this is again coming back to what we studied earlier. The potential energy is equals to the kinetic energy. Okay, so the 1 over 2 kx squared, which you calculated just now, is equals to 1 over 2 mv squared. 1 equals to, because, okay, how did I get this 1? Because you already calculated in question number 1. Okay, equals to half the mass of the ball. What's the mass of the ball? 0.01 kg. 0.01 times v squared. Okay, so you calculate, you will get v equals to 14.142 meters per second. Okay, so we see again this energy thing happening. Okay, even in Hooke's law. Okay, also quite important. Diagram 11.3 shows a toy gun. Okay, so you have yada yada yada. So you have a spring, you have a dart. Okay, the good news is this is a making a choice question. So what do we want? We want suitability, specifications of dart and spring to make the dart travel for a longer distance. Same question as the ball bearing just now. Almost the same lah. Okay, almost the same as the pistol yang kita tembak tadi kan. Okay. So let's get down to it now. What are we looking at? We are looking first at the specifications of the dart. Okay, do we want a smaller mass? The dart is this one. Dart yang kita tembak lah. In the previous question, it was ball bearing. Now it's a dart. So obviously we want a smaller mass. Okay, smaller mass means it is lighter. Okay, or you can say able to move faster because it's lighter mah. Okay, you can also say that. But remember, don't put 0.02. Say low mass or smaller mass of the dart. Okay, remember that. The shape should be aerofoil or aerodynamic. Obviously, we want aerodynamic. Aerofoil is for sayap kapal terbang. Okay, aerodynamic. We want it to be aerodynamic to decrease air resistance. Okay. Oh dear. My writing. Air resistance. Okay, third one. In the spring itself, do we want a thicker spring or do we want a not so thick spring? Obviously, we want a thick spring lah. Okay, and this one I have already said it quite. No, sorry. The thickness of the spring wire. The thickness of the spring wire should be big. Yeah, okay, should be big. Okay, so that you can increase the spring constant. Okay, or you can also say the elastic potential energy or to increase the elastic potential energy. Okay, either one is fine. Okay, the diameter of the spring coil, okay, should be small. Okay, because we want a same thing lah, increase the spring constant or to increase the uh, elastic potential energy. So the best one will be choice X. Okay, the dart and the toy gun. So the best choice will be choice X. Yeah. Oh, because it's a combination of toy gun and dart pula kan. Just give me a while. Let me just see something. Yeah, actually this should be decrease the diameter of the spring. Hold on. This was what question? Kelantan. Oh, okay. Yeah, sorry. This should be decrease. Decrease the diameter of the spring. Yeah, we want to have a thick wire but a small diameter so that it is more elastic. Correct. Okay, fine. So that the spring constant is higher. Okay. Let me think about it and then I will write it. Something seems off with that, but okay, let me think about this first. Okay, well, let me finish explaining. I'll think about it. Saya mau balik kepada inilah, the diameter of the spring coil. It should be small, but I'm trying. Yeah, it's the holidays. My brain doesn't work during the holidays, but okay. Let me come back to you on that. Okay, ini diameter of spring coil. Okay, we'll talk about it. But thickness of spring wire definitely. Okay, itu wire itself must be big. Okay, to increase the spring constant. Okay, but the diameter of the spring coil means the spring itself lah yang berlilit-lilit tu. Kita mau diameter besar ke diameter kecil. Let me come back to you after we finish this. Okay, let me just come back to you after we finish this. Okay, so now we go into light. Okay, now we're going to light. I'm going to show you, unfortunately lah, okay, in this light experiment, there are only two subtopics which are constantly tested among all the experiments lah. But walaupun dia adalah dua subtopic, there are two different experiments for each subtopic. Okay, so I want you to take note of this lah. There's not a really very big difference. It's just that you have to adjust it a little bit lah. Okay, when you look at the question. So in the Penang question number 3, okay, you are given a projector, okay, form a clear and sharp image on the screen. And then when the lens is adjusted nearer to the object, this refers to the object distance. Okay, the screen has to be moved further. This refers to the image distance. So this is the relationship between the object distance and the image distance. When you move the object distance smaller, okay, the image distance must be bigger. Okay, so then the apparatus is normal, convex lens screen. Okay, so this is how the, oh dear. Okay, let me see if I can rotate this. Kejap. I thought I had this. Okay, kejap, kejap, kejap. Oh, I don't think I can rotate this. Can I rotate this? I don't think I can rotate this. Okay, never mind, never mind, never mind, never mind. Let me see. Can I rotate this? No, I can't rotate this. I can lah. If I rotate this gun, then it will be very small. But okay, you know what? Since I think a lot of you are doing a screenshot, so I'll just show you this lah. Okay, you can take a screenshot of this. I'm just going to move my head like this so you can see lah. Okay, so image distance depends on object distance. When the object distance increases, okay, when the object distance increases, the image distance decreases. Okay, atau bila kamu gerakkan the projector nearer to the screen, then the screen has to go even further away. Okay, so you change the object, you change the object distance, then, you increase the object distance, the image distance will decrease. Okay, so the aim is there. The standard constant variable, okay, is always the focal length or the power of the lens. Kalau lens kan, most of the time, constant variable is power of the lens lah. Okay, so try not to get stuck over there lah. Okay, so this is how the experiment will be like. Okay, you have a bulb, okay, and then what you do is you just change the object distance, then you measure the image distance. And what do you measure it with? You measure it with a meter rule. Okay, so it's a pretty easy one. You letak the convex lens, then you change the object distance. Sorry, you adjust the convex lens. Don't adjust the bulb. Let me see. Place the convex lens. Yeah, see, so you place the convex lens. The first one is 12. You can also choose 10, 20, 30, 40, 50. No problem at all. This contoh hanya menggunakan 12. Okay, so you put it at 12 cm from the light bulb. So the first one is 12 cm. Okay, then the next one is 16, 20, and so on and so forth. And then after that, you switch on the power supply, the screen is adjusted until the sharp image of the filament is formed. Means on this screen over here, you can see the gambar of the light bulb. Okay, and then after that, you measure lah. Okay, jarak dari sini sampai sini kan, you measure using a meter rule. Okay, then you repeat the experiment and do the same thing again. Okay, but that is kalau the variables are object distance and image distance. Okay, if the variables are object distance and image distance, this is how the experiment will be like. Okay, and the reason why I say this is, okay, if you're taking a screenshot, better take a screenshot of this now because I'm going to move on already. 5, 4, 3, 2, 1. Okay, because in the next question, this is from Malacca. Okay, this is from Malacca. It is almost the same experiment, except that it is slightly different. Okay, look at this. School signboard being observed through a convex lens. So the school 3.2, same, tapi the lens is moved nearer. Okay, now this is not object distance and image distance. Sorry, this is not image distance because the image distance is the same. Yeah, okay, the image distance, sorry, not the image distance. What is changing now is not the image distance. Ini bukan apa yang dia suruh kamu perhatikan. They're not asking you to observe the image distance. They're asking you to observe the image height. Okay, so slightly different. The experiment is exactly the same, except that now what you are measuring, okay, is not the image distance, but the image height. So this experiment, the manipulated variable is the same, the object distance. Okay, because you're moving the lens far and near. Okay, when you're moving the lens far and near, moving closer to the signboard lah. Okay, but what is the responding variable? Responding variable is the image height. Okay, so but the relationship is the same. Okay, the bigger the object distance, okay, the smaller the smaller the object, the image height. Okay, the experiment is the same. Okay, constant variable is still the same, the power of the lens. You're still using the same lens. Okay, please avoid using the words type of lens. No, the word type of is no longer an acceptable answer. Type of water, type of lens, type of whatever lah. Okay, totally doesn't exist. Tolong jangan jawab begitu. Okay, so this is this is the experiment and this is the same setup. Cuma if the question is like this lah, kalau dia punya soalan adalah macam Melaka 2020 that talks about the image height, all you have to do is change the image height. Okay, image height. This one is image height. Image height. Okay, then what you do is the image height is measured using the meter rule. Same experiment, just change the word image distance to image height. Okay, these two questions, image distance and image height, have been asked in different trial papers dalam tahun-tahun sebelum ini and also in SPM. Both questions have been asked before. Okay, in SPM. So, please take note of this. There is a difference in the variables, but the experiment is exactly the same. Okay, so that's the first type of experiment that you may see in our SPM this year. Okay, kalau light yang keluar lah. Now, another type of experiment, okay, is this one. So this is Putrajaya 2020. Okay, question number 3. So diagram 3.1 shows the observer's eye. Okay, can see the crab at an angle of 20 degrees. Okay, then diagram 3.2 is at 40 degrees. Okay, and then after that you are given a glass block, a ray box, and other apparatus. Now, whenever you see this 20 degrees, you kind of know that this is a refraction experiment. Okay, and if I remember correctly, we did this experiment last year. Sorry, we did this experiment 2 years ago when you were all in Form 4, and you did it with me lah. Okay, so actually you need to go back and look at your PK experiment to look for this experiment. I don't think I gave the answer. Oh, I do have the answer. Okay, so this is a refraction experiment where the MV is the angle of incidence. Okay, angle incidence 20, angle incidence 40. When it's 20 is 15, when it's 40 is 30. So the RV is angle of refraction. Okay, and what is the CV? Don't say the type of glass block. Okay, it's always the refractive index. Okay, of, you can say glass block lah, since we're going to be using glass block. Okay, so because this is a glass block over here. So how is the experiment like? Oh dear, I'm sorry. Experiments like this. Except that when we were doing this kind, we didn't use this kind of this one. We used a square block. Do you remember? We used a square block. We put it on a white piece of paper, and after that we draw. Okay, so kalau di dalam kamu punya experiment, okay, if I remember correctly lah, okay, this is how you drew it, right? Okay, then you have a ray, so you draw the ray box over here. Okay, and then after that you have then you draw this. That's all you draw actually. Yeah. Then you label lah. This is the glass block. Okay, this is the this is the ray box. Okay, then you write down here this I, and then over here lah, actually this is R. Oh no, sorry, this is R. Okay. Now, so how would the experiment be? I've already given you this. Okay, so the experiment will be set up the apparatus, direct a narrow beam, use the first angle is 10 degrees. Okay, then the refractive ray is marked. the refracted ray is marked, and then the refracted angle is measured using a protractor. Okay, don't forget to include the material, the alat yang kamu guna untuk measure the protractor. Okay, and then after that you repeat the experiment using 20, 30, 40, and 50, or any other empat lagi angle lah, okay, yang kamu mau pakai. So this experiment we did before, okay, in this one, when you were all in Form 4, feels like a lifetime ago, huh? Yeah lah, but there you go, okay, and so if you're not sure about this one, or if you can't really see what I'm showing right now, go and look back at your PK experiment. Okay, it should be there, except that kamu kena adjust sedikit itu PK experiment supaya dia adalah dalam format kertas 3. Okay, make sure that you adjust it so that it is in the paper 3 format. Okay, I'm going to give you 5 seconds to take a screenshot of this if you want. Okay, 4, 3, 2, 1, 0. Okay. I want to come to this last question. This is also reflection. Okay, except that this is an experiment that we have not done before lah. Okay, it does not involve ray box. You know why? Because if you take a look at the alat kan, Negeri 9, paper 3, look at the alat, tall cylinder, water. Okay, this is the real depth and apparent depth experiment. Okay, dalam nyata dan dalam ketara. Like the depth of the swimming pool kan, sebenarnya dia 2 meters, tapi yang kau nampak 1.5 meters gitulah. Okay, so real depth. So take a look at this. Diagram 3.1 shows a coin in a glass, under a glass block. So the glass block is over here. Diagram 3.2, same coin, but this is perspex. Okay, different material. Okay, now the observer notices that the image of the coin in the glass block is nearer compared to the perspex. Okay, so since the observation is the apparent depth, okay, so that's the RV. The RV is the apparent depth dalam ketara. Okay, yang dia nampak, not the real depth. Okay, so what is the MV and the CV? Okay, the CV is the real depth because dia punya kedalaman yang original is the same. Okay, the real depth is the same. So what's the MV? What is changing in both these situations? It is the type of material, but we cannot say the word type. Okay, so we need to talk about the density of material. This is especially tough because we didn't really cover this experiment when we were doing light. Okay, and this is a very unpopular experiment lah. It's actually not even in your textbook. Can you imagine? Okay, and very few reference books carry this experiment. But because it came out in Negeri 9, I must cover it lah. Okay, and I want to cover it. The manipulator variable is the density of the material because you change the material, glass block, perspex. The RV is the apparent depth and the CV is the real depth. You always make sure that the real depth is the same. What changes is how you observe. Okay. Now, so what you're going to do with a tall cylinder and water? Okay, it's like, apa ini, tall cylinder and water. What am I going to do with this? Okay, this is how the experiment is. Okay, I'm going to give you some time to take a screenshot before I explain it now. Okay, I'm going to show it to you in 2 parts so that it's easier. Okay, so this is part number 1. Okay, you want to take a screenshot of this now, better take it now. So the apparent depth depends on the density of material. Sorry, we don't use the word type of anymore. Okay, the apparent depth depends on the density of the material. Kamu tukar bahan, kamu tukar dia punya ketumpatan, okay, dia punya apparent depth yang kamu nampak okay, adalah berubah. Now, when the density of the material increases, the apparent depth decreases. Okay, or the depth of image lah. Okay, let's not talk about this. So when the density of the material increases, the apparent depth decreases. Just now, you saw glass block. Okay, dia adalah lebih dekat. The apparent depth is smaller. When perspex block, okay, the apparent depth is smaller. Sorry, the apparent depth is bigger. So, okay, the apparent depth is bigger. Dia lebih dalam lah. Okay, because glass block is very dense compared to perspex. Okay, so when you increase the density, the apparent depth will decrease. Okay, so to investigate done, manipulator is done. The fixed variable or the constant variable is the real depth. Okay, you don't have to do this if you want, but real depth is enough. Okay, now the materials are like this. Okay, if you see, you put a beaker and then you put a water, you put a pin or a coin, usually it's a pin lah. Okay, you put a pin over here, then you put another pin over here, then you have a ruler. Dan kamu menengok dari atas. This is your eye over here, observer. Okay, so you look at it from the top like that. Okay, now let me stop here for a while and sorry, okay, this is part 2 of this one. If you take a screenshot, take it now. Okay, 4, 3, 2, 1. Okay, so this is the steps. So you fill in the beaker with 1000 cm of water. Okay, 1 liter of water lah. Okay, then you put 20 gram of salt into the beaker and then you stir. So this is how you change. You don't change the material, you just add more salt. Because when you add more salt, you increase the density. Okay, so when you increase the density, the apparent depth is supposed to be decreasing. Okay, so you place a pin O into the water. You adjust this pin until adjust the pin 1 by observing the beaker until it appears in line with the image. Okay, bila kamu buatkan, dia akan off bah. Okay, until you adjust the pin I, okay, you adjust this pin that is on the retort stand sampai dia adalah sebaris dengan gambar yang kamu nampak di dalam air. Okay, this is an extremely difficult experiment to do. Okay, let me be honest with you lah. Okay, one of the reasons why I don't like to do this experiment in the lab because it's very difficult to do. It's very difficult to get it right. Okay, it has to be. This is a real. We call this a pipe dream experiment lah. In a very perfect world then this experiment will be successful. Okay, I've done this a few times lah. Okay, and I can do one. Okay, it's just difficult lah. You must have the patience of an ox in order to actually do this experiment well, but it can be done. Okay. Then you measure the apparent depth of the straight line. Okay, so this is the apparent depth. Sorry, from here, the alamak. Okay. So this is the apparent depth. Okay, over here. From the surface of the water until where this pin is. Okay, then you repeat the experiment with different masses of salt. Kamu tambah lebih banyak garam. Okay, so you have 30 grams, 40 grams, 50 grams, 60 grams. Okay, so what you will have is the mass of the salt and the apparent depth. You don't actually even have to have this. Okay, you can always write the operational definition. Okay, the mass of salt in water represents the density of density cepat. Okay, you can write the operational definition as such. Okay, then you don't even need to do something. So here you can change to mass of salt and apparent depth. Done. Okay, so 30, 40, 50, 60, 70. Make sure there are 5 values. Leave the apparent depth empty as always, and then leave the graph just the axis and no graph. Okay, don't draw the graph over there. Okay, and that's how you would do this particular question. It is, yeah, ini adalah, as I said lah, this is a very rarely asked experiment lah. So it is a little bit apa? It, maybe for some of you kan ini macam, kenapa ni macam saya first time tengok ini kan? I would say that, you know, you have 7 other experiments lah. Okay, you have 9 other experiments. Okay, we have covered 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is the 10th experiment. Okay, you have 9 other experiments. If you want to let go of this experiment, you just pray to God very hard that that this question doesn't come out this year. Okay, but I would say that this is not a very popular question. Okay, I don't think I have ever seen this question at all. Kecuali dalam soalan trial lah. Tapi kalau dalam SPM kan, I don't think I have seen this question before. Okay, so yeah, so this is the experiment that has to go with the Negeri Sembilan ke that? Yeah, the Negeri Sembilan paper. Okay, the Negeri Sembilan paper, question number 3. Okay, I know time is almost up. I want to go back to that question just now sebab sampai sekarang saya masih memikirkan tentang itu. But can you just give me like 2 minutes? Let me go and look up something and then I will come back to you with the answer. Okay, let me pause this for a while. Okay, so let me get this right. So in this question, okay, in Terengganu, okay, Terengganu 2020, this is correct. We need a smaller diameter coil of spring, okay, because yeah, the spring with the small diameter has a bigger spring constant. Okay, so ini adalah betul. Okay, so when I was talking about the Terengganu question, this is correct. Okay, the spring with the small diameter, that means dia punya size begini kecil, bukan begini besar, okay, begini kecil, it has a higher spring constant lah. Okay, so that's what we want. But in the previous, apa ini? Okay, in another question, this one, I think this is the one where I made the mistake. Yeah, I'm pretty sure I made the mistake here. So over here is, we want the spring, okay, we want the thickness of the wire to be this one. We want the diameter of the spring to be smaller. Okay, we want the diameter of the spring to be smaller. Okay, so this is to decrease the diameter of spring. Okay, so that the spring constant can increase. Yeah, okay, so I want to make sure that this is correct. Because all we want is for the ball bearing to go further, we want the spring constant to be higher. So higher spring constant means you need to have this thicker spring and, you know, smaller diameter. These are the 2 ideal conditions. Okay, obviously you use steel also lah. Okay, it's higher spring constant. High spring constant, and then it's better for the ball bearing to go further. Yes. Okay. All right. I think that's about it for today. My dog suddenly feels like he's going to fall sick. Okay, so so I hope this has been helpful for all of you. And I will, let me end this video and then I will talk a little bit more.